That's exciting. Apparently, half of what we did yesterday deleted, so let me write these back. What example did we stop on? Because it apparently disappeared. $58. Okay. Alright, so then number 60, we've got cotangent squared theta times 1 plus tangent squared theta. So I'm looking to see if there or what I can rewrite to simplify down as much as possible. So when I see squared things, what do I think of first? The Pythagorean identities. So does one of them have something like 1 plus tangent squared, or maybe a manipulation of that? What is that equal to? Secant squared. So I'm going to first of all rewrite this as cotangent squared theta times secant squared theta. So now, just as a refresher, the instructions wanted us to rewrite things in terms of sine and cosine. So how can I rewrite cotangent squared in terms of sine and cosine? And it would be the same way as if it wasn't squared, except for it all square on it. Yep, cosine squared over sine squared. And how can I rewrite secant squared in terms of sine and cosine? One over cosine. Yeah, 1 over cosine squared. So now these things are being multiplied. So I can cancel the cosine squareds top and bottom, which leaves me with 1 over sine squared theta. And what is 1 over sine squared equal to? Cosecant. Yes, cosecant squared theta. Let's see, 62. Secant of theta minus 1 times secant of theta plus 1. So this one actually requires us to do it a little bit differently, okay, because of it just being like secant of theta minus 1. It's not like one of the Pythagorean identities because it doesn't have the squared in it, although it kind of looks like, that form. So any guesses before I tell you what we need to do on what we could do with this?
It would just be tangent.
How? Because you're... How about if instead, disregard this for a second, you had x minus 1 times x plus 1. What would you do with that? So ignore this. FOIL, and this is a special type, but what would it end up giving you?
Squared plus x.
I'm going to write it because you said it. So you've done x squared plus x, now what?
Minus 1x plus x. Wait, no. Minus 1.
Minus 1. So that stuff goes away, so this is a difference of squares that gives you x squared minus 1. So now, this looks kind of like that, right? Secant minus 1 times secant plus 1. Kind of looks like this. So this is going to end up giving us, we're replacing x with secant, so this would give us secant squared theta minus 1. Now, is that something we have? Or we could get there? What Pythagorean identity has a secant squared in it? What does it say? Come on, I know we can read. So tangent squared theta plus 1 equals secant squared theta. So if I subtract 1, I have tangent squared theta equals secant squared theta minus 1, right? Now that matches that, so that tells me that this is equal now to tangent squared theta. That's what I was talking about yesterday. Sometimes we have to move stuff around within them. So it's like find what identity has that in it and see if we can make it look like that. Now, it won't always work out. Sometimes that wherever we get there might be the end result, or we might have to do something different with it. But most of the time, you should be able to move stuff around and get it to look like that. All right, 66. 1 minus sine squared of negative theta over 1 plus cotangent squared of negative theta. So with this one, the first thing I want to do is I want to look at those, sometimes I call them negative angle identities, but the even and odd identities. What do I do when I have a negative inside of sine? Does it just go away or does it go out front? Like in the angle. It goes out front. So the top of this is going to become 1 plus sine squared theta. What about cotangent? Does it go out front or? No, it goes away.
Yeah.
Are you sure?
Yeah. No.
It goes out front also. So this is going to be 1 minus cotangent squared theta. Now, does this look like something that I know? What is the Pythagorean identity that has sine squared? It doesn't have to look just like this, but what does that one say, the one that has sine squared in it? There's only one of those. It says sine squared plus something equals something.
Sine squared plus theta plus cosine squared. Theta is equal to 1.
Okay, so that says sine squared plus cosine squared is equal to 1, but I've got 1 plus sine squared. When I do this and manipulate it, this would be 1 minus sine squared. So is that the same thing? No. So I just have to leave the top. How about the bottom? What one deals with cotangent?
Plus cotangent squared equals cosecant squared.
1 plus cotangent squared equals cosecant squared, but I needed 1 minus cotangent squared, so are those the same thing? No. So this would just get left like this, and this would be the end result of that one. There's nothing else I can do to that one. All right, one more, then we'll be done. 74 secant squared theta minus 1 over cosecant squared theta minus 1. So what Pythagorean identity relates this? I already have it written up here. Tangent squared plus 1 equals secant squared. So I need secant squared minus 1. I can subtract the 1 over. So tangent squared equals secant squared minus 1. And I'm just not writing the thetas to make it go faster. But so that means that this top part can be replaced with tangent squared theta. Now the one that relates cosecant and 1 is this one right here. So 1 plus cotangent squared is equal to cosecant squared. But I need cosecant squared minus 1, so subtract 1. Cotangent squared equals cosecant squared minus 1. So I can replace the bottom with cotangent squared of theta. So now, how can I rewrite, well, there's a couple different ways I could do this. How can I either rewrite cotangent in terms of tangent, or how could I rewrite tangent and cotangent? It'll probably be easier for you to see it if we do it in terms of, how can I rewrite tangent? Let's do it that way. It'll be easier. In terms of sine and cosine. Sine over cosine, so this will be sine squared theta over cosine squared theta all over, how can I rewrite cotangent squared in terms of sine and cosine? Cosine over sine. So now I've got a fraction over a fraction, so what do I do to get rid of that?
Keep change.
Yeah, keep, change, flip, multiply. Yeah, all the same thing. So the top will be sine squared theta over cosine squared theta times, flip the bottom one, so this will become sine squared theta over cosine squared theta. And then we just multiply this one. Nothing can cancel out, so I just have to multiply across the top. So that would become sine to the fourth of theta over cosine to the fourth of theta. And this is just something that'll be kind of like a bonus for you later, but if you see like, and it's to any power, but like sine to the fourth of theta like that, is the same thing as saying sine of theta raised to the fourth. That'll come in handy with stuff we do later, but just for reference for you right now. All right, so I gave you those two problems yesterday. If you felt like you remembered all that and you don't need to do them, you don't have to do those ones. But in addition to that, the new stuff that you have to do, 53, 55, 57, 59, 63, and 73 are ones that you need to do for practice. So the stuff that we'll do in 7.2 is kind of a continuation of this, but it's called verifying identities. So basically, like, we'll verify that what they say something is equal to is actually what it's equal to. So it kind of like this one, you have to find the end result. The ones we'll do tomorrow, they give you the end result. We just have to show how to get there. So it's kind of like proofs from geometry without having to explain the reason why. So